We need to find the absolute extreme values of f of x equals sine squared x on the closed interval from 0 to pi. If you have a continuous function on a closed interval, the absolute min and max always exist. So between these four options, it's going to be D. Like, we're going to choose this one here. But all we need to do is find, well, what is the max, what is the min, and what are the x values where they occur. You could start this problem by actually just graphing the original function itself and look at the interval from 0 to pi. So that's everything from here to here. So, I can actually already see the answers without even using any calculus. The largest value is right here, and it looks like that's at 1 for y, corresponding to pi over 2 for x. And the min values are here and here. So one is at x equals 0, the other is at x is equal to pi, and they both have a min of 0. So they do exist. But really the point of this question is to use calculus to find those values. The approach that you can take is on a table of values, so for x and then y equals sine squared of x, you need to check the endpoints of the interval, which are 0 and pi, but you also have to include any critical points. That's where your derivative is equal to 0. So, you check the endpoints, you check the critical points. The y values, there's going to be a largest and there's going to be a smallest. The largest is the max and the smallest is the min. So that's the procedure using calculus. So let's actually take that approach here. All right, so I'm going to take the function f of x is equal to, and maybe I'll write it as sine of x squared. This is what sine squared x means. We need to take the derivative and then set it equal to 0. The derivative is, we bring the 2 down front, we copy down the sine of x, we subtract 1 from the exponent, but then you have to multiply by the derivative of the inside of the parentheses, which is cosine. So this, if we want to simplify it or write it so it looks nicer, is the derivative. And we need to set this derivative equal to 0 and then figure out all the values of x within this interval and only that interval where this is a true statement. So there are several ways that you can solve this equation. Actually, you can even divide 2 to the other side and write this as sine x times cosine x is equal to 0. You could graph this thing and try to see the x values where it's equal to 0. But if we have these two separate factors, wherever sine of x is equal to 0 and wherever cosine of x is equal to 0 will give us solutions to this equation. And again, this only works if one side is actually equal to 0 itself. So you can split this apart and say, all right, I'll set sine of x equal to 0 and solve that for x. And I'll also set cosine of x equal to 0 and solve that for x too. So sine is equal to 0 on multiples of pi. So 0, pi, 2 pi, 3 pi, 4 pi, and so on. But also negative pi, negative 2 pi, negative 3 pi, and so on. And the only values that are critical points that fall within this interval are the endpoints itself. So you don't have to add them to the table again. So between 0 and pi, these will be the only values you have to consider. So we're not getting anything extra from cosine of x. From sine of x. But cosine, well, this might throw in another value too, and I'm pretty sure it's going to. Where's cosine equal to 0? Well, that is not multiples of pi, but multiples of, pi over 2, 3 pi over 2, 5 pi over 2, and so on. And all the negatives of these values as well. So of the numbers that I have listed where this is equal to 0 that fall within this interval, there's only one, and that's pi over 2, this. So I'm going to actually include that in my table. So we've narrowed it down. Using the calculus approach, in this interval, there's only 3 numbers you have to check. 0, pi, pi over 2. If you put 0 in place of x and compute sine squared, you could do this in a calculator. You could actually figure it out by hand, but that's 0. Sine squared of pi is also 0. Sine of pi over 2 is 1, and if you square 1, you get 1. What does all of this mean? It means that we do have a max. It's at pi over 2, and it takes on a value of 1, but we also have a min. In fact, there's 2. These are the min values. So in terms of how you would enter your answer into MyLab, so the absolute min is, well, that number that's a minimum is 0, and it occurs at 2 x values. It occurs at 0 and pi. The max is 1. It only occurs once, and that's at a value of pi over 2.